Hey everybody, I'm Chili. Welcome back to 3D Fundamentals, Tutorial 1. Today I'm going to be giving you a quick tour of the framework code that we're going to be using for this series. Now some people are going to be coming to this series not from my previous series, so they're not going to be familiar with the framework. And this is just going to be a very quick overview of what's in the framework and how it generally works. I'm not giving a full explanation here of how Direct3D is initialized or how windows are created. That shit is going to come in the Direct3D hardware series. Here, it doesn't matter. Now, before we get started, you're going to need the code. So you go to the wiki page, links in the description, and you click on the link for the GitHub repository. You open up the repo, you go to clone, and you copy this URL here. Then you're going to open up Visual Studio. And you're going to go Team Explorer and Manage Connections, and you're going to clone the 3D Fundamentals repo. Now, you might want to give it a different local path on your computer. I'm going to put mine on the desktop. I'm going to name the folder 3D-fund and clone that motherfucker. When it's done, you want to select that repo, double-click it. And you'll be here now, 3D Fun or whatever you called yours. And now you double click on the solution to open that up. And Bob's your uncle. And you can go to Solution Explorer, you can open that shit up. And here we are. Here's the framework. All the files right here. Now the framework is just a minimal code base to give us direct access to the pixels on the screen, plus some stuff like keyboard and mouse input. And it's just to let us play around with graphics and stuff like that at the lowest level possible, at the pixel level. So let's start our tour at the graphics class. Open up graphics.h, and here you got the graphics class. This is basically the raison d'etre of the whole goddamn framework. And the centerpiece here is the put pixel call, because this is what we use to put pixels on the screen. Now the way that graphics works in the framework is you've got a buffer, you've got a block of memory in system memory and on the CPU end, and you just write values into that block of memory, and those values represent pixels. And when you're ready to present that to the user, you copy this block of memory onto a texture that's in GPU memory. And once you do that, then you have to do an extra step of rendering that texture to the frame buffer, to the screen. And you do that just by rendering a couple of triangles with the texture coordinates, the proper texture coordinates, and you get your frame that you composed on the CPU, you get that onto the screen. That's how it works. So these put pixel functions, they write into that system memory. We also have a utility function drawLine, and that's just an algorithm for drawing a straight line, and it just calls put pixel basically. If you go peak definition, you can see here, down here, we're just calling put pixel inside of a loop here. So we'll be using drawLine a little bit for the wireframe. I'm not going to go into it. I assume you already know, y equals mx plus b, and maybe you know Bresenham's algorithm, whatever, it doesn't matter. You should know how to draw a straight line. I'm not going to go over that. I'm just going to give you the function. We're going to use it. We're going to draw some wireframe before we get into triangle drawing. What else we got here? Begin frame, that just clears out the system memory buffer and resets the buffer so we can do our put pixels onto a clean slate. End frame does that stuff I just talked about before, where it copies it to the texture and then draws the texture to the frame buffer. That's all that end frame does. So all the details about how this stuff works and how graphics is initialized, they exist in graphics.cpp. You can look at it. It's probably not going to make a lot of sense to you. It's just a lot of API bullshit. It'll make a little more sense after you finish this series, because you know more about how 3D graphics works, and the API is based on 3D graphics, right? But I will explain all this bullshit in the hardware 3D series. Don't worry about it. We'll get there. But now we're just talking about basic, theory. This bullshit is going to get in the way, so let's put it out of our mind for the time being. Now, graphics has a bunch of stuff in it. Most of this stuff is just Direct3D API bullshit, but Surface is a class that we will be dealing with, and it is a class we made in the framework. Now, surface represents a buffer of memory, system memory, that holds pixels. Basically, it represents an image in system memory. And this surface represents the buffer that we drew our put pixels to, the thing that will eventually be displayed on the screen. And let's open up Surface here, and it's got a bunch of utility functions. And you can see you can call put pixel to put a pixel onto a surface. And in fact, if we go back to graphics, we see that graphics put pixel, let me find it, just calls system buffer.putPixel. So surface put pixel is where the drawing is actually done. And you see here, it's just assigning a value to an array. So it indexes into the array, two-dimensional, X and Y, and assigns a value there. No magic, it's pretty simple. So we can put a pixel, we can get a pixel if we want to see what's on the image. We have alpha blending put pixel, which will blend with the whatever is on there. And what else? We can get the width, we can get the height, we can get a pointer to the actual raw buffer if we need it. We can clear the thing, we got all sorts of different, we can copy, construct, and that's all good. And there's two very useful functions here. From file will load a surface and return it by value, and it'll load most kinds of files like PNG, JPEG, bitmap, anything. Save will save a surface to a bitmap file. Only bitmap, not JPEG, not anything else. But yeah, that's surface. It allows us to create images in memory that we can manipulate. We'll use it for when we create texturing and stuff like that. We'll use it to load our textures into system memory. And you can also use it to load sprites or whatever, but we're not going to be doing sprites in this series, I don't think. How it manages the memory for the buffer is it uses a unique pointer for that, so it's very nice automatic cleanup of the dynamic memory. All right, what else we got? We can see here that the buffer, the block of memory here, is an array of color. So what is a color? Well, let's check it out. Colors.h. And that's a class, and it just represents a pixel. So it's a packed value, RGB, just your standard ARGB value. Alpha is at the very high byte of the 4-byte value, and then red, green, and blue is at the very low byte. And you've got functions here that will, set individual packed values inside of there or return individual packed values. And constructors that will construct based on various different values, RGB or whatever. And you've got a little set here of static const expression color, preset color values. So instead of having to type, 255, 255, you can just type white. Colors, : white, and that'll get you there. And that's about it on the purely graphics end of things. What else you got here is, I guess the next thing is windows, right? Because you can't create a direct 3D device without having a handle to a window. So you need to create a window if you're going to want to make a game or a direct 3D application. So the main window class here, it handles the creation of the window in its constructor, and it handles the processing of Windows messages. And you got a couple of functions here. You can check to see if the window is active, if it's minimized. You can display a message box. You can kill the window, that'll end the program. And you can get the arguments that were passed to the window when it was run. Probably won't be using many of these things. It's a kind of a weird setup I've got here. It's pretty cool, but it's kind of complicated. I won't explain it all here. There's a bunch of dumb bullshit going on here. But basically, yeah, you create the window and then you pass it on to graphics, and that's about it. Now, main window contains two objects, public access objects. And these are very important because they allow us to access the keyboard and the mouse input. Because keyboard and mouse input comes in through Windows messages, so it makes sense to put these guys into the main window object. And main window processes those messages and then queues up the events and the statuses into the keyboard and the mouse object. And you can access these objects and you get information about the input states. So there's a lot of functions in here. There are basically two ways of accessing the input. One way is there's a queue of events, and you can pull events off the queue in the order in which they happened. Key press events or mouse move or mouse click events. And the other thing you can do is you can check the current state of the input device. So you can check what keys are currently being pressed, or, where the mouse pointer currently is on the screen. It's probably easier if I show you the header file instead of showing you the implementation. But yeah, for the mouse, it looks like this. There's a lot of functions, but they're pretty self-explanatory. Get the position, get the X position, the Y position, check to see if left is pressed, right is pressed, if the mouse is in the window, and then you can read a message or an event off the mouse event queue. And mouse events, they look like this. They have a type. You can get the type. You can check to see what the X and the Y position of the mouse was at the time of the event. You can check to see what the state of the keys being pressed was at the time of the event, so on and so forth. And it's the same deal for keyboard, right? You can read key events. Generally, the way it works is you have a while loop, and while the key is empty is false, so while not key empty, you read key into event, you handle the event, and you keep doing that until the queue is empty, and then you continue. That's how you do it. But yeah, I'll give you examples of that later on. It's not a big deal. So let's switch gears here. Let's look at the entry point to the whole program, the main. So here you got your main, and I'm using exceptions here. I'll talk a little bit about them in a second. But ignoring the exception, the try catch, all you got here in the main is you create a main window object. You pass it instance and arguments, and it creates the window and does all that happy bullshit, sets up the message loop stuff. Then what you're going to do is you're going to create game object, and I'll talk about that in a second, but this just encompasses the entire game, and it also contains the graphics inside of the game object. So that's why you have to pass it window so it can initialize the graphics object. And then all you do is you process the messages of the main window, and once you process the message, it's going to return a value, a boolean, as to whether or not the program is exiting. Because if it receives the quit message, then you want to, end the program. So it's going to process messages, and if it returns true, meaning we're continuing, then it processes a frame of the game. Then it goes back, processes Windows messages and game frame. And it does this infinitely until process message returns false, and then we exit the program, return 0. So let's take a look at game then. If we go to game here, it's very simple. You've got a function called go, and you got a couple private functions here called compose frame and update model. And in the data, you've got a reference to the main window, and it contains the graphics object inside of game. And if we look at the header file for game, again, it's super simple. All you do here is you initialize the Windows reference with Windows reference that was passed in, and you initialize graphics. So you call graphics as constructor, and you create the graphics object. And game.go, all it does is it calls a sequence of things that happen every frame. Begin frame, then update model is where you put your game logic or whatever. Then compose frame is where you put your drawing code, and then end frame is where it all gets, presented to the user. So this file is we're going to be spending a lot of time, coding our shit up in. Alright, we're almost at the end of this shit show. Second last thing I want to talk about is we got some utility classes for doing math bullshit. So, we've got rectangle, and it just encompasses, a freaking rectangle. And you can do a bunch of dumb bullshit like clip one rectangle to another one, or check to see if rectangles overlap, or if one rectangle fully contains another one, etc. Sometimes useful, won't be using it that much maybe, we'll use it a little bit. What we will be using a lot of, or similar to, is this vec2 class. So this class gives us basic vector operations. We can add, subtract, multiply, and divide by scalars. We can add vectors together. What else can we do? We can multiply vectors together, and that means dot product right here. And, we can normalize, and we can get the length of the vector, and we can compare vectors. It's all good. It's just templated, so you can have integer vectors, you can have float, double, whatever kind of dumb, weird vectors you want to have. Obviously, we're doing 3D, so we're not going to spend a lot of time with Vec2. We're going to pretty quickly upgrade it to Vec3, but it's the same general idea. Not much is going to change, really. And the same thing for matrix. We got matrix 2, and this will allow us to, perform matrix multiplication on our vectors or multiplying matrices together. And so you got some, basic multiplication operations for your matrices and some static functions that will generate useful matrices like identity matrix, rotation, and scaling. And that's basically it. That's all the useful parts, all the parts of the framework that you're going to be interacting with at one point or another. Now you might say, Chili, you've skipped over some files here. What's all this stuff you didn't talk about? What are you trying to hide? And that's just a bunch of dumb bullshit. But for completion's sake, I'll go over it. So Chili exception. Exceptions, I hope you know what an exception is. And I use exceptions to propagate errors in this framework. So for example, if we go to graphics.cpp and we look at the initialization code here, we see that basically every call I'm making here to the direct 3D functions, I checked for failure. And if they fail, I throw an exception here. And, it's a Chili graphics exception. So all exceptions in the Chili framework like this, they inherit from Chili exception, and you can just get some information. You can get a note. You can get what file the exception was thrown from, the source file name, the line, location, which is just the line plus the file name, and all that dumb bullshit. And that is used in main.cpp. So we have try and catch in here, and we try, and whenever an exception happens, we catch it down here, and we handle it. So if it is a Chili exception, we print a message with a bunch of information. If it's just a standard library exception, we print a message with less information. And if it's just any kind of exception, we just say some kind of exception was caught, don't know what it was, oh well. Now, Chili math, there's goddamn all here. It's just define pi, and we define a templated square function that just multiplies something by itself. Pretty simple. Now, Chili win is how we include the Windows Sdk header, and it does a bunch of stuff. It defines what target version of Windows we're doing, and it also it basically disables a whole bunch of bullshit to increase the compile times. So a lot of stuff that we're never going to use, it gets disabled in the framework here. And it also disables min-max, because that messes up the min-max from the standard library. And it defines strict, which, to be honest, I'm not exactly sure what that does, but I heard it was good, so I threw it in. DirectX Error is a source file that was provided by Microsoft. It used to be part of the SDK, but it has been removed. But you can still download it separately, and it takes DirectX, Direct 3D error codes, and it gives you useful messages. And so that's helpful. I put it in here. The GDI Plus Manager is basically all it does is it initializes, its constructor initializes GDI Plus, and the destructor deinitializes it. It also does reference counting, so if you have any object that depends on GDI Plus, you can include this in the object, and it will initialize if it hasn't already been initialized, but it won't initialize it twice. And every time the destructor is called, it decrements this ref count, and when the last manager is destroyed, it deinitializes GDI Plus. And this is important because, where is it? Surface.h, it has functions to load and save images, and those ones use GDI Plus. So we have to make sure we initialize that. And I use this to automatically handle the initialization. I think I include it in graphics here, GDI Plus Manager. So it's the first thing that gets created when you create graphics. And that makes sure that GDI Plus is available for all sorts of graphics needs. I don't know. And when you destroy the graphics object, it's the last thing that gets destroyed. And so GDI Plus is uninitialized at the very end. Resource.h is just basically included for the application icon. And the same goes for these resource files here. You got the application icon and the resource script here. Shaders are the shaders that are used to actually draw the texture to the triangles. And very simple shaders here. Just vertex shader does nothing, just passes the data onto the pixel shader. Pixel shader just uses the data to sample the texture, and that's it. And that's it. That's the whole shebang. Everything you didn't want to know about the Chili framework in however many minutes this is after I edit this bullshit. So to wrap things off, how about a demonstration of the framework in action? Alright, so what I'm going to get you to do is click Team Explorer, click on Home, make sure you're here, and then click Branches. And what you're going to do is you're going to open up this Remotes folder here, and you're going to double click on T1 -* and what this will do is this will bring this branch onto your local machine and update all your source files. You should know Git already, but just in case, that's what it does. And what I'm going to do is I'm going to set branch points like this for every tutorial, and you can use that to jump between the code in the different tutorials, little checkpoints. So here's the code for our little test demo here. It's not much of it, as you can see. If you go over to the header file, you've got a few constants defined, not many variables, just a theta for rotation, and a vector of vectors. Confusing, but this is obviously standard container, and this is a mathematical vector. So it's just, basically an array of points that are going to define some model that we're going to be rotating, and the model is the star. So if we build this, we'll get all the shit. First it compiles the shaders, and then it compiles all the source files and the bullshit, and it makes the thing, and we go start the debugger, and you see we get a rotating star. You press space and you can pause the rotation. Beautiful, amazing, I love it. And I hope you don't need me to really explain too much how this code works. You should be able to read it and sort of get an idea, but, just in case. And these constants here control parameters of the simulation. You've got the inner and outer radiuses for the star, the velocity of rotation, the number of flares, the overall size. So when you take this, we can increase this to, say, like 15. And if we try to run that, our star would have a lot more points on it, like this. It's pretty simple. Now, how the star is generated, it's fairly simple concept here. We're using cosine and sine to generate points on a circle, right? And we're generating two sets of points, inner and outer points. So let me just run this. It's easier if you look at the picture. So yeah, the star, two circles, concentric, and you're generating points on either on the outer radius or the inner radius. You're alternating between them, and then you draw lines connecting those points, and you get a star type shape. So yeah, just points on a circle, two different radiuses. We alternate, so we're checking I, and if I is odd, then what is it? I don't know. Mod 2 equals 0. So if it's even, we take the outer radius. If it's odd, we take the inner radius. Doesn't matter. So you generate the model. This is just done once in the constructor. And then in here, you are going create a const vector that is the translation. And that just moves the model from the top left-hand corner to the middle of the screen. So we're just doing screen width divided by 2, screen height divided by 2, and a transformation matrix, which contains the rotation and the scaling matrices. And then we copy the vertices from the star. So we use auto because I don't want to type out vector, whatever. I'm lazy. I type auto, create a vector of vertices, and copy our star vector. And then for each vertex in the star container, multiply by the transformation matrix, and then we add the translation. Note that we can't do the translation in the matrix here. We can't multiply that in here because we only have two-dimensional matrices. If you want to put translation in this system, you'd need three-dimensional matrices for a two-dimensional system. Similarly, you need, four-dimensional matrices for a three-dimensional system, but we'll talk about that later for sure. So yeah, transform your vertices. Then for each vertex, you're going to draw a line between that vertex and the next one. And then at the very end, you're going to draw a line between the first vertex and the last vertex. And then you're all done. In your update model, we are going to be increasing theta, which is the angle of rotation, by some value, and that causes the thing to rotate. That's what animates the whole thing. And we don't do this. We pause this process if the space key is pressed, and that allows us to pause the rotation. And that's it. That's how she wrote. Now, there is one thing that I want you to note here, and it's going to be mildly important. The order of multiplication of matrices and matrix and vector in this system is different than what you might be used to, depending on, where you learned about that stuff. So here we're using what's called a row vector, and what that means is the vector is on the left, and you multiply the matrix on the right. So you take a look at this diagram here. We're doing the second case here, case 2, row vector on the left, and then you multiply your matrices like this. And this is the system that DirectX is based on. Column matrix is the kind of notation that's more associated with OpenGL and just general, math class, if you've ever taken this stuff in high school or university or whatever. But we're using this system here, and this is important mainly when you're talking about the order in which transformations are being applied. So in a system like this, if you're applying a series of transformations to this vector with matrix multiplication like this, the way it's going to happen is first this one is applied, then this one, then this one. So it happens left to right, which is the opposite of what you might be used to from, say math class or whatever. Just something to keep in mind. But that'll about do it for the framework tour. It's just something I wanted to get out of the way before we start on the 3D stuff proper. I just wanted to make sure that we're all starting on the same page here. And in the next episode, we'll take our first true steps into the realm of 3D graphics. If you're interested in looking a little deeper into the framework or whatever, I'll put some links on the wiki to, the reference pages on the framework, but you don't really need to know it in that much depth to follow this tutorial. You'll be able to glean what's what just from seeing what I'm talking about. This tutorial isn't about the goddamn framework we're using. It's about the math and the concepts of 3D graphics. So it's not that big of a deal. Don't sweat it. Thanks everyone for watching, and a special thanks to all my Patreon supporters, and I will see you soon with some more 3D fundamentals.